turbo engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
questions,
Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists.
Hello, this is the show where we bring you the latest breakthroughs in science, technology and medicine. I'm Adam Murphy, and this week we are looking at the science behind the headlines. From the latest with COVID-19 to weather in space, we'll be taking a closer look behind some of the biggest stories of the moment.
The Naked Scientists podcast is powered by ukfast.co.uk.
Joining me to chat about all these news stories this week are two very special presenter friends, and they are space scientist and emeritus professor John Zarnecki from the Open University and pharmacist Bahija Raimi Abraham from King's College London. Between us, we'll be talking to a range of interesting guests dropping in over the next hour. So first of all, over to you, John. It's great to have you here. How are you?
I'm surviving.
Aren't we all?
Yes, it's of course just like everybody else. Some days are more of a struggle than others, but I can't complain. I've got a nice garden, and I've become much more aware of nature on my doorstep. And as you'd expect, I look up at the sky on those days when we're able to do that. But sadly, I missed that meteor that shot across the sky a few days ago.
And speaking of that kind of recent thing, what else in the headlines space-wise has been catching your eye scientifically?
Well, it was, I suppose, that meteor that flashed across the sky and was seen in many parts of the UK. I don't know if you saw, but various people have done some modelling of the fragments. It was seen to break up in the atmosphere. And the modelling suggests that some fragments might have landed somewhere north of Cheltenham. And so some intrepid explorers have been looking to see if they could find any fragments of this visitor from space. And, the meteors, shooting stars are quite common, but to actually find a fragment on the ground is relatively rare. I think the last time in the UK was about 30 years ago. That's something that rather caught my attention.
Did you see, because I only saw it earlier today, about an hour before we started, did you see the new Elon Musk's new rocket? He managed to make it do a flip, land, and then it exploded.
Yes, that's the Elon Musk Starship. So that's his latest, biggest rocket. I mean, it really is a big beast. And I think that, the idea is that might eventually take payloads and even astronauts to the moon and Mars. I think there have been several attempts to land this rocket, and this ostensibly it worked. I mean, it came down, you can see in the footage, it came down and it landed fairly softly, but not quite softly enough. And apparently what happened was that a few minutes after the landing, I think one of the fuel tanks had ruptured because it was a slightly rough landing. Fuel was leaking and there was a fire and an explosion. But I think it did demonstrate the ability to relatively soft land this very large rocket.
And then, Bahija, over to you. So you're a pharmacist, lecturer in pharmaceuticals at King's College, founder of King's College London Fight the Fakes, and you lead your own research group. So can you tell us about all of that? What is it of all the things you get up to?
I know, that's a bit of a mouthful, isn't it? With my research, I start off with my research. So the core pillars are aging and global health. And then I have several cross-cutting themes ranging from pharmaceutical manufacture and innovation, looking at novel ways to make drug delivery systems, novel ways to make new medicines, and in particular looking at sort of nanotechnology approaches as well. Then looking at the therapeutic and multi-morbidity aspects of infections. The reason for that is we have to remember that a patient is not just, let's say, for example, I have an interest in malaria. So a patient may present, they may have malaria, but they may also have diabetes or, hypertension. And I think sometimes in healthcare and in medicine, we tend to look at the patients with a focus of just whatever we're interested in. So I'm really interested in looking at that sort of what we call multi-morbidity and exploring the therapeutic elements. And then as I mentioned, the nano-facilitated drug delivery strategies in infection prevention and treatment. And then the last of it is actually this issue of falsified, substandard and counterfeit medicines. And the reason why that's added in is because, as I mentioned, I'm quite interested in malaria, but actually on my journey with my research and the work that we do, it came to my attention, really, the impact fake medicines have on so many different things, on antimicrobial resistance, on, patient outcomes and things like that. And it became something that I realized I really wanted to get involved in beyond the research. So to get more involved in the advocacy and awareness element of things. And so that's why I did establish the King's College London Fight the Fakes campaign, which aims to provide advocacy and awareness for the global issue of falsified, substandard, and counterfeit medicines. But then on top of that, putting a face to, because it can be very faceless thinking about, the impact of fake medicines. But this campaign, we actually sort of, I guess, put a face to this issue so that people really see how important it is.
Brilliant. Bahija, thanks very much. And we have a load of stories coming up, everything from the sun to the surface of the earth to COVID to flu, which we will be getting into over the next hour. First, and probably unsurprisingly, we're looking at the most recent updates in COVID-19. The UK government has its roadmap out of lockdown, and there's news that the vaccines seem to be working, which is more than welcome. But what is happening right now? Well, he's usually on the other side of the microphone, but virologist Chris Smith joins us right now to unpack the most recent COVID stories. Hello, Chris. To start off with, there's some new variants that have popped up in the news, like one from Brazil. Can you tell us what those are about?
Well, all viruses mutate and change as they go and grow through a population. So if you've got parts of the world where there are lots of cases of the virus, effectively that's lots of rolling of the genetic dice. The virus has many opportunities to change and evolve, and it will disclose variants. That happens just naturally. But if you've also got a situation where there are people with partial immunity to the virus, people who are immunosuppressed for some reason, or people who've been vaccinated, then you're putting in the way of the virus a new kind of challenge, an opportunity to evolve better under those circumstances. And so what we've seen from Brazil is an emergence of a virus that has a certain constellation of genetic changes. It overlaps with virus variants from South Africa, which carry many of the same constellations of changes. And we've also had variants here in the UK as well, which have similar constellations of changes. In other words, patterns of genetic changes that they're all being arrived at independently by the virus, but it's settling on those changes because they confer some kind of advantage to the virus. And in the case of the Brazilian variant, perhaps it's a difference in its shape or structure that means it's more likely to evade the immunity of the population. In the case of the South African variant, similar. In the case of the variant picked up in the UK, it's more transmissible. It's conferring an advantage on the virus. It's very important we keep an eye on these variants because they could ultimately lead to a virus that not only spreads better, but could bypass the protection conferred by the vaccine. And of course, that's where we're putting enormous emphasis at the moment as our route out of the pandemic.
And speaking of vaccines, there's a story out that perhaps we could see this, especially this Oxford vaccine, as something other than an injection, as a pill or a nasal spray. How is that going to work? I can't picture a vaccine that isn't a needle.
Well, it's intriguing, isn't it? And as scientists and researchers have quite accurately pointed out that the way in which we're administering these vaccines, a number of them are based on what we call viral vectors. They use a modified virus to deliver the genetic code from the coronavirus for its spike protein, which is the business end of the virus, which we want to trigger an immune response against. But the viruses that are being used to do that are cold viruses, adenoviruses, to give them their proper name. And they don't naturally infect people through an injection into a muscle. They normally spread through the nose and throat, through the air. So what researchers are saying, quite reasonably, is, well, hang on a minute, why don't we try presenting these things as an inhaled vaccine, something you breathe in as a sort of mist of virus particles, or even package them up into a sort of pill that you would just pop a pill and you'd basically infect yourself with these vaccines which confer protection against coronavirus at the same time. So they're actively pursuing this because just imagine the prospect. If you had something that was inhalable or a pill, you wouldn't have to drag people to vaccination centres. You wouldn't have to basically ask people who are needle phobic to have an injection. And that is a deterrent for many people. You'd have something you could mail out to people, far more likely that people will take up the offer. And you won't be having to run complicated vaccination centres. You just need the postal service.
And to come to you, Bahija, what factors decide what form a drug takes, if it can be a spray or a pill or a needle or what it has to be?
Yes, that's a really good question. And it's what pharmaceutical scientists and also even drug discovery scientists, they have to consider you generally want to understand what we call the physicochemical properties. So this is the solid state, the state of the drug. There are several different factors like its solubility. How soluble is it? As humans, we are majority water. So we want drugs that are water soluble. But most drugs are actually poorly water soluble. So that makes it such a challenge to try and figure out what route is best for it to be delivered. And so when you're designing a medicine and thinking about where it should go, you're also then thinking about the patient. So you're thinking what is going to be easier for the patient. On top of all of that, you're also thinking about cost, right? So it's just so many different things in one go. If you're thinking about cost, then generally the cheaper methods or the cheaper manufacturing processes are those that have been long established for years. So that's why most of the things come as tablets, capsules. When we're thinking about vaccines, generally speaking, we just think injection. Let's find a way to have it as an injectable. But as anybody who's had a vaccine or has to take injections, that's not pleasant. Some people have real fears of needles and things like that. So you start to think about other routes. And so this is where we start to think about the route that has the best patient acceptability is actually the oral route. But you've got to think what else is going on in the mouth. So saliva, the enzymes, that could break them down. So this is when people start to look at other routes such as the nose, because we breathe all the time. And, there are lots of studies about, the nanoparticles, microparticles from pollutants that just in the atmosphere and can actually just from normal breathing get into the deep lung and things like that. Ultimately, if you're thinking about what the patient would prefer, then it would basically be anything but an injection. Then the second option would be, can we take it as a pill?
One other story that's come out is there's a big link between, is it death from COVID and the rates of obesity in the UK, which might go some way to explaining why there's so many deaths in this country. Can you tell us a little bit about that story and what it might mean?
Well, there's a report out literally in the last couple of days looking at the prevalence of obesity around the world and then asking, how does that marry up with the likelihood of a person getting COVID? And what you see are countries like the UK, where we are number 3 or number 4 in the world in terms of our obesity rate. In other words, if you pick an adult at random from the population, how likely are they to be obese? And then you ask, and how does that compare with the number of people who, when they catch COVID, as in the virus that causes COVID, go on to develop life-threatening or lethal coronavirus infection? And the answer is there's a really strong correspondence. And one of the reasons being postulated for why countries like the UK have such a high mortality rate from coronavirus is because we have such a high obesity and therefore also potentially diabetes rate. And many people often point to Taiwan or Vietnam or Thailand and say, why is it that these countries, for example, have such low levels of coronavirus mortality? How are they controlling the virus? What are their public health initiatives that are so successful? And the answer is that some of their public health initiatives are so successful, yes, but if you look at the number of people in the populations of those countries who are overweight, they're fewer than 1 in 5. If you look at the number of people in the UK who are overweight, it's more like 1 in 2. And this is the pattern that's repeating itself across the world. And really, we probably need to take this seriously, because it's one thing to dwell on a coronavirus pandemic, but the pandemic we have all walked into in the last 20 years or so is an obesity pandemic. And this is going to cause ultimately far more death, far more disease, far more disability than any pandemic from a virus. And that's an unarguable fact. With maybe half the world's population now overweight, we know that that is a massive disease risk factor for all kinds of conditions. And so actually solving that one would immediately also help us to address the coronavirus problem. And it's interesting that the countries that do have very low rates of coronavirus death, so they're still catching and they're still passing on the coronavirus, it's just people aren't dying of it. In those countries, there are far more interventions and initiatives aimed at helping people to maintain a healthy weight compared with countries like our own. And so we really do need to take a good look at ourselves and ask, what do we need to do in order to tackle this invisible but far more lethal pandemic that is creeping up on us?
We have the UK's plan to get out of lockdown in the next few months, and we should be back to, all things going well, some kind of normalcy by July. Do you think that's a reasonable roadmap out, Chris?
Well, Boris Johnson thinks so. I don't think it's a coincidence that he announced in his press briefing last week that on the 21st of June, there would be no legal constraints on what people can do together. And the 19th of June is Boris Johnson's birthday. So I think he's got a big party planned. But more seriously, I do think that it's a reasonable road out of this. The vaccine success has really surprised even the people who thought it would work. And when you look at the data that we have now for asymptomatic transmission, for people who are in their older, latter years, who are protected from coronavirus at outstandingly high rates, far higher than we had perhaps anticipated. And you see this being mirrored not just across the UK, but in other countries, Israel, for example. It gives us enormous confidence now that, in fact, this is going to work. And I know, notwithstanding the worry over variants, we still think that the vaccines are going to provide defense against even variants of the virus. It just means that perhaps we might still tolerate a higher level of transmission of the virus through the population. But nevertheless, we will not see the mortality that we were seeing on the scale we were seeing it, thanks to this vaccine initiative. And that's an amazing thing. And I think that does give us great reassurance and great confidence that, in fact, this is our road out of it. And I felt more optimistic in the last couple of weeks, having seen the data I now have, compared with, many weeks before. So I think there's every reason to be very, very optimistic. But what we don't have yet is a solution for the rest of the world. And as Melinda Gates from the Bill and Melinda Gates Foundation said very, very presciently right at the beginning of all of this, if there's COVID anywhere, there's COVID everywhere. Because at the end of the day, unless we sort the whole world's problem out, then it will keep coming back, it will remain a problem, and it won't go away. And so therefore, the job is not done until we've done it everywhere. And that's what we've got to remember. Otherwise, we're just in a gilded cage here in the UK. We fix our country, but we can't go anywhere. And we don't want to be like that. We want the world open again.
And just to come to you, John, what are your thoughts on this kind of thing?
Chris, we hear a lot about modelling of the spread of the virus, but when you were talking about variants, I just wondered, it made me ask, is it possible, and does anybody try to model the development of variants?
Yeah, they do. And they not only model the development of these variants and the likelihood they're going to arise, they also model the impact that they will have. Because when making models of disease, you take into account a number of factors, such as how many people have got it, how close those people live to each other, how many journeys they make every day. In other words, how many shopping trips, work trips, the size of a household and so on. But you also take into account transmissibility. You also take into account the degree of immunity in the population. And so you factor in, if you've got a variant that you think might have the ability to bypass immunity, you program that into your model, saying, well, we think the immunity of the population will be successful at a certain percentage level, and you would adjust that accordingly to take into account the prospect of these variants arising.
Chris Smith, thank you very much.
Welcome to the Naked Gaming Podcast with me, Chris Barrow.
And me, Lee Milner.
Every month we look at the latest gaming news.
The primary way for the farm pigs was really to nose the joystick up and down.
We review the biggest releases.
You can easily sit down, play it, switch off, a bit like Crash Bandicoot, but instead you're inside a horror movie.
And because there's a simulator for almost anything, we play some of the strangest ones available.
I'm kind of like dragging the pigs. The pigs are laying eggs, and then coins are coming out of the eggs.
The Naked Gaming Podcast from The Naked Scientists. Download it now wherever you get your podcasts.
Across the hour, we are looking at the science behind some of the stories in the news at the moment, with the help of our special guests, pharmacist Bahija Raimi Abraham and space scientist John Zarnecki. On the way, the successor to the Hubble Space Telescope. Everyone loves a good nature show, and there's a fresh crop appearing at the moment, putting them back in people's minds. And as the climate continues to change, and not for the better, the messages these shows contain is more pertinent than ever. But what goes into making them? Elizabeth White is a producer of some award-winning nature documentaries, and she joins us now. So Elizabeth, you were an academic initially. How did you get into TV?
I was indeed a biologist at Bristol University with an interest in certainly animals and animal behaviour, but I didn't really have any idea what I wanted to do after university when I started. Very sort of fortuitously for me, I happened to be studying fish around the time that the BBC was making the Blue Planet series, the original Blue Planet series. And I was a diver and super keen on marine life. And I sort of applied to do some work experience at the BBC and ended up helping out quite a lot with the original Blue Planet because they needed someone who had a passion for fish and could identify fish. So it became a part-time job I did while I was studying for my PhD. I was very torn. Did I stay in science or did I try and move into the media? And I think I felt very much as if I wanted to do something that was more creative than sitting in a lab. And so I moved towards the TV direction and luckily found myself at various points moving into television production, or at least initially as a television researcher.
And what kind of things did that let you work on? What have you done?
As I say, my passion was really in marine side of things. And in fact, the last part of academic work I did had a grant to go and work with the British Antarctic Survey down in Antarctica. And I remember sort of coming back from that thinking I was super, super passionate about getting back to Antarctica somehow. Within a few weeks of returning from that, I was called in for an interview at the BBC, and it was a series initially about animal migration. And I'd worked on eels, so I knew a bit about animal migration. So I was offered a kind of a short-term researcher job, and then that extended. And initially, it was a lot of work that was marine because I was a diver. So I was lucky enough to work on some tropical programs. And then out of the blue, a series called Frozen Planet came up, which felt like it ticked all my boxes for me. And so I interviewed for that and was lucky enough to get a job as a researcher and an assistant producer on that series, which was a lot of fun, going to both poles and doing a lot of stories on penguins and ice whales and things like that. And that really kicked off my passion for what you'd call landmark television, so the big sort of blue chip TV. And that's really where I've stayed for the last 10, 12 years, working on series like Planet Earth 2. And now funnily enough, it's all gone full circle. I'm now working on another series of Frozen Planet. So I'm working on Frozen Planet 2.
And what's going into Frozen Planet 2? What's it about, other than a frozen planet?
Well, Frozen Planet 2 is kind of a more contemporary take on the series that we made 10 years ago. It still has fabulous stories of penguins and polar bears, but this time we've opened it up to be all the cold regions. So it's really the story of all the cold and snowy places. So we have mountain stories. We have a film purely about mountains and high altitude cold regions. We have films about the Arctic and Antarctic, of course, and about the snowy forests. But I think what we've done with this one, much more so than the original series, is to focus on how these places are changing through the eyes of the animals. So in all of the programs, you'll see stories where appropriate of the changing climate and what that means to the animals. So it's a very contemporary viewpoint. Still got the same absolute lovable animal characters and stories and beautiful photography, but with a very sort of contemporary twist.
And given all these things that you've made, what is it you hope people take away from them?
I think most of all, I hope people feel more connected to the natural world. I think all of us who go into wildlife TV do so because we're passionate about the outdoors, we're passionate about the planet, we're passionate about animals. And I think so many people today don't necessarily have access to nature, and certainly in most of our modern lives. I mean, a lot of my time is based in Bristol, where my home is. So I'm not outside in the polar regions all year and so on. And I really feel like I appreciate a lot by seeing it on television, and I see places on TV that I will never get to go. I think for me, it's about that connection, hoping that people feel more connected to these places and then understand how important they are and how they fit into, us as a species.
And then for you, what kind of things have changed since you started working in the TV business?
When I started, and I think it's also true of science to some extent, I think as a woman, it was a much harder environment to work in. If you look back sort of, 100 years, women obviously didn't work in science. If you look back to when I was born, my mother's generation couldn't go to Antarctica with the British Antarctic Survey. Women weren't allowed. And I think when I started in television, it was a world that felt like it had a lot of men. There were a lot of roughy-tufty explorer types making TV. And I think one of the nicest things is how that's really shifted. Certainly in sort of 10 years ago, we started to see some really fantastic female producers coming through. And they've obviously moved on, become series producers and execs. And now today, the business feels, in terms of the editorial side, much more even. Women can be fabulous storytellers. Women can be fabulous camera operators too. And I think that's the side of the business that's slower in catching up. There are a lot less women operators out there than men. But certainly on the directing, producing, logistics side, production management, it feels like a really thriving industry for women to work in.
And then, Bahija, just to come over to you for a moment, do you love a good nature documentary? What are your thoughts on watching them?
I do love a good nature documentary. In fact, I was trying not to 100% fangirl when Elizabeth was talking. I am obsessed with Frozen Planet. I like anything to do with the sea. Because I just think it's still such an underexplored area, and also the Antarctica as well. So yeah, I love it.
And what about you, John?
Yes, of course. And one of the things that amazes me, I mean, apart from the incredible locations and animals, is how over the years, because I've been watching these programs for many years, how I suppose the technology, but the photography, how it's changed dramatically over the years. I mean, it's totally stunning now. I mean, I still remember the grainier images that we used to see, and cameras being more fixed, less flexible, less sensitive. So, I mean, that aspect, I think, has given enormously greater opportunity and potential to program makers.
Have you seen that sort of technology shift, Elizabeth?
Very much so. Yes, when I started, it was very much still on tape. I missed film. Film, thankfully, was largely in the archive, but everything was on tape. And then it all shifted to be digitally captured. And now, of course, the great thing is the size. So cameras are so much smaller, which makes a big difference to us when we're sort of taking things all around the world. You know, we're all very conscious of our carbon footprints. And if you can reduce the amount of excess baggage and technology you take with you, that's fabulous. But also having smaller cameras means obviously you can do more with them. So these lovely gyro stabilized rigs that allow you to sort of move around and as if you're flying and floating. And then obviously more than anything that's, for me, I think has transformed the world is the use of drones, being able to put a drone up in the sky somewhere where you would never get a helicopter. I mean, it means a lot less disturbance to the wildlife, number one, but also allows you to get a perspective that you just couldn't get before. So it's exciting. It's a really exciting time to work in this industry, actually.
Amazing. And I think everyone out here agrees that you have an awesome job. Elizabeth White, thank you very much. But up to Mars now, and the new rover that has landed on the surface, Perseverance. It's gotten everyone here very excited. I know I'm thrilled to see what it gets up to. But what has Perseverance actually done up on Mars, and what's it going to do? Matt Bothwell from the Institute of Astronomy here in Cambridge joins us now. So, Matt, what has Perseverance been up to since it landed on Mars?
It's been doing a few things. So one of the things that you would expect it to do is do all kinds of tests and calibrations of its system. So once this thing lands on Mars, that's the end of a very, very long and violent journey, right? So since scientists last kind of tinkered with it, it has traveled hundreds of millions of miles through space and come in and landed on a planet starting at tens of thousands of miles an hour and eventually has come down resting safely on the floor. There's an enormous amount of checking that scientists need to do to make sure that all the systems and all the components are still working. There's also quite an important kind of software side of things where there are different software programs that are involved in actually getting to Mars versus being on Mars. And so a big thing that the team is presumably doing right now is switching from those two modes, right? So going from I'm traveling to Mars mode to I am driving around on Mars mode.
And once it starts driving around, what's it going to start doing?
So one of the biggest things is going to be looking for a nice site for the test flight of Ingenuity, the first helicopter, the first drone on Mars. I guess a nice link back to talking about use of drones in photography. There's now going to be a drone on Mars. And one of the things that Perseverance is going to have to do is scout out a nice place for Ingenuity's first flight. So that's going to involve using its cameras, driving around and looking for a nice flat surface to take this test flight on.
And what are the other sort of big mission aims of Perseverance then?
Well, the ultimate mission aim is to look for signs of ancient life on Mars. Mars is one of the best places that we think there might have been life in the past. Even though Mars is this dry desert nowadays, thousands of millions of years ago, Mars had water on it. It had liquid oceans and lakes and rivers. And given that life emerged on the young Earth in exactly these conditions, it's a reasonable guess that there might have been life on Mars billions of years in the past. And so Perseverance's main mission is going to be to look for signs of this ancient life. One thing it's going to do that's never been done before is take samples of the Martian soil and prepare them for return to Earth. So far, all missions to Mars have just examined the soil kind of in situ and radioed back the results. The Perseverance rover is going to dig up some soil samples and then prepare them in a way that in the future, a mission might be able to actually bring them back for Earth examination, which is very exciting.
With all this, these are some lofty goals. Do you think it's gonna meet them? Or are you excited to see what comes next?
Well, I think the question of are we alone in the universe, which is what this is really about, right? It's a small way of getting at the question of are we alone in the universe. Obviously, everyone has their fingers crossed for a positive answer, right? I mean, if Perseverance discovers life outside our planet, it will be one of the most momentous discoveries in the history of the human race. But this question is, I think, is also very interesting because the results are fascinating whichever way the answer pans out, right? If Perseverance gives us the green light and says it has found evidence of ancient life on Mars, that's fascinating. And then we can all start kind of getting philosophical and wondering what that life might have been like. But if the answer is that Mars is completely barren and always has been, that's also philosophically interesting. It means our Earth is much, much more special than we might have thought previously. And so that's going to give us a lot to think about as well. And so whatever way the answer pans out, I think we're going to have a lot of thinking to do.
Bahija, what's a pharmacist's opinion on a Mars mission? This is very much not your usual wheelhouse.
I am so fascinated by Mars, just by astrophysics, just the world of physics. It's just amazing because I think, as you know, pivoting on what Matt said, if from this mission we can find out that there's life or has been life on Mars, there currently is, I don't know, it's just going to be so amazing to even just start expanding one's thoughts in this area.
And John, is there anything else going into space or anything in the space missions that you're excited about coming up?
Let me just first say, I mean, it is a fantastic mission, but I've been involved with a mission which landed instruments on the surface of Titan, which is Saturn's largest moon. It took us 7.5 years to get there. So we rather look down on Mars as being, you know, in our backyard and rather easy and local. But joking apart.
It's just there.
Well, you know, it really is in our backyard. It only takes a few months to get there. And only one probe has landed on the surface of Titan. But you asked me about other missions. I think, what am I getting excited about or interested in? Well, there are other missions at Mars, of course, several. And one from Europe is called TGO, Trace Gas Orbiter. It's actually a collaboration between ESA, European Space Agency, and the Russians. And that is trying to look for trace gases, that's gases in the atmosphere that exist in tiny concentrations, and in particular methane. So there have been reports over the years, both from space missions and from the ground, of small traces of methane. And of course, on Earth, one great source of methane is biology, is animals, for example. And so that's one of the reasons why this mission was developed. And this is more sensitive than any of the other missions or ground-based telescopes that have detected methane or claim to have. And yet, in a year or so of operation, it hasn't seen anything at all, despite the fact that it's working very well. So that's a bit of a mystery, and you know, not quite sure where that story is going to go. Otherwise, of course, we've got the James Webb Space Telescope, in some ways the successor to the Hubble Space Telescope, that is due for launch later this year. And I think every astronomer, whatever their interest, is going to be watching that with bated breath.
And I think we'll have to leave talk of Perseverance there, but this will hardly be the last we'll be reporting on it. Matt Bothwell from the Institute of Astronomy here in Cambridge, thank you very much.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Music in the programme is sponsored by Epidemic Sound, perfect music for your audio and video productions.
This week we are looking at the science behind the headlines, and across the hour I am joined by space scientist John Zarnecki and pharmacist Bahija Raimi Abraham. And coming up, how do you forecast weather in space? So, given that we are in March with a year ahead of us, I'd like to know what you think is coming in the year for your fields. Bahija, if we could start with you, what's the big news happening in pharmacy, or the big breakthroughs that you think are on the horizon?
Well, we know that 2020 has actually been a year that we saw big advances and advancements in technology. And over the last few years, there's been growing interest in the use of artificial intelligence and machine learning in drug discovery and drug development. And I really see this expanding even more so. There's already one big company that is focused on drug discovery using artificial intelligence, and there are more that are popping up. And I really feel that this is something that we're going to see more of. Having artificial intelligence, machine learning to support drug discovery, so that's identification of new chemical entities, drug development, which is making the medicines, having the help of something, artificial intelligence, AI, has been shown to speed things up, to get improved accuracy of targets. And I just think there's going to be so much more that we'll see in that area. So really just technology and merging that in a synergistic way with health and drug development and medicine, I really think that's something we're going to see more of in not just this year, but in the future.
And John, we were talking earlier, you mentioned the James Webb Telescope. So can you tell us a little bit about that? What's that hopefully going to do if it actually gets launched this year? I know there's been a chain of delays.
Well, the James Webb, I think, is seen by most people as the successor to the Hubble Space Telescope. It's different in many respects, partly, of course, because Hubble was launched in 1990. So it really is old technology. James Webb is very different. One of the main differences is that it's going to be looking in the infrared part of the spectrum, as opposed to the visible and the ultraviolet, as with Hubble. And this means that it's going to be able to look in particular in some regions of our galaxy and the universe that are sort of obscured by dust, for example. And we're going to be able to peer into the cool universe, the colder regions, the regions where stars are forming, for example, and that are completely or pretty much obscured to the Hubble. So that's very exciting. And it's an enormous telescope. I can't remember the aperture, but several times bigger than Hubble. And it's in fact much too big to fit under the fairings, under the nose cone of the launch vehicle. So it has to be sort of deployed like the petals of a flower once it's in orbit. And that's going to be pretty scary.
Do you think it has the potential to be the same kind of, paradigm shift the Hubble was?
Yes, absolutely. And one area where it could make a real impact is in the study of exoplanets. So, of course, that is something that the discovery of the first exoplanets actually happened after Hubble was launched. We'd never heard of real exoplanets when Hubble was launched. And it will have the capability, in particular, to look at the atmospheres of some of the exoplanets that we've already discovered. We know of about 5,000, I think, already. But we now are just really on the verge of being able to look at the atmospheres of some of these exoplanets and looking at the constituents, some of the gases that make up the atmosphere. And there's just the possibility that one could see, and I realize I'm sticking my neck out here, that you could see some indication of life or at least biological activity by looking at particular biosignatures in the atmosphere of these exoplanets. So that's, I think, one of the many areas where JWST could be incredibly exciting.
And I think it will be interesting to see what comes out in either field. Bahija and John will be sticking around with us for the rest of the programme. But next up, given the year that we've had, you might be forgiven for forgetting that the flu was such a big deal, as we've had a lot in our plate virus-wise. But rates of flu have fallen dramatically, perhaps because of the same lockdown and social distancing measures we've been using against COVID. And while that might seem wonderful in the short term, it might have some negative effects further down the road. Derek Smith from the University of Cambridge joins us now. So, Derek, why might the next flu season be so bad, and how bad could it be?
Adam, we don't know how bad it is going to be or not. Like with many situations with what's going on with COVID-19, we've just never been in this situation before in our lifetimes, and in times when there has been such good recording of data and really knowing what is going on. We may have a relatively mild season if COVID continues and there is still social distancing going on, or if COVID circulates and somehow manages to competitively exclude flu, or we may be in a situation where people haven't had much flu circulating for a couple of years and it comes back with a vengeance. And we have to be prepared for the latter. It's important that people continue to get their vaccines against flu if they are at risk. But the truth is, we don't know what's going to happen.
How do we usually vaccinate against the flu? Because it's a bit of a moving target, isn't it?
Flu is a moving target. From a scientific perspective, it's absolutely fascinating to study because of that. But of course, from a public health perspective, this makes it an extremely difficult thing to vaccinate against. Yeah, the flu evolves to escape immunity that we have. So it has this seemingly endless capacity to incrementally change and evade the immunity that we might have built up with prior infections against flu or prior vaccinations against flu. And so for people who are at risk for severe influenza, this is why the recommendations are that these individuals are vaccinated every year, because in most years we change at least one of the 4 strains of flu that's in the flu vaccine.
If it's going to change so much from year to year, how do we pin down any kind of correct answer for what a vaccine is going to look like?
Yeah, there is a really astonishing global network of people working in hospitals and GP offices who are noticing people who come in that look like they might have influenza, taking throat swabs, sending those to a so-called World Health Organization National Influenza Laboratory in their country. Those swabs analyzed there to see whether or not they really are flu. And if they are, then those samples sent to one of 5 WHO so-called collaborating centers across the world. There's one in London, one in the United States, one in Tokyo, one in Melbourne, Australia, and one in Beijing, China. And those strains are analyzed in a great deal of detail in terms of their sequence and in terms of whether or not their phenotype has changed to escape immunity. This is happening in almost 140 countries across the world, thousands of people involved. And yeah, it's an amazing global operation. And much of that infrastructure that has been built up in those countries is the same sort of infrastructure that has been leveraged for tracking COVID.
If the rates have dropped, though, does that mean there's a lot fewer samples with which to try and make a prediction? Could that end up being a problem?
Yes, that's absolutely right. We rely on all of that global surveillance to see what is happening with the evolution of the viruses worldwide. And in a typical year, there are a small number of millions of samples that are taken in this way that I described throughout the world. And the viruses that filter through to the collaborating centers as being representative of what is circulating, it's typically in the region of about 10,000 per year. And this year, it's in the hundreds, not 10,000 or so. So the vaccine choice this year we made with a much smaller number of viruses. There's still a lot of surveillance that is going on looking for flu. So we really do know that there is very little flu that is going on. And yeah, it has made the choice of which strains should go in the flu vaccine much more difficult. Nevertheless, it has been identified that there is some variants of one of the types of flu, the so-called H3 viruses, that have emerged in a couple of countries and have spread internationally. And indeed, so the H3 component of the vaccine has been updated for this year's recommendation that took place, discussions over the last couple of weeks, and the decision announced last week.
And what does that uncertainty sort of translate to in practical terms? Does it mean that, that the vaccine could miss the virus entirely, or is it will lower how effective the vaccine is? What could the knock-on effects be?
These are so-called vaccine mismatches, and they do reduce the effectiveness of the vaccine. It's never the case with any vaccine, just like we know with the COVID vaccine. Not everybody is going to be protected who is vaccinated, but a large proportion of them are. And when there is a vaccine mismatch like this, when the virus has evolved after we make the vaccine choice until the vaccine actually gets used, yes, then that vaccine mismatch reduces the effectiveness of the vaccine, which means that some people who wouldn't have normally noticed that they would have gotten flu will get flu. But there's three main categories of how the vaccine protects. The same with the COVID vaccine, whether or not it protects against people feeling like they're ill, so protecting against infection, whether or not it protects against severe disease, and then whether or not it protects against death. And even in years where there is a vaccine mismatch, even though more people might not be protected from infection with flu, it's still in many cases going to be protecting them from severe disease and from death.
Derek Smith from the University of Cambridge, thank you very much. This week, I am joined by space scientist John Zarnecki and pharmacist Bahija Rami Abraham as we're diving into the science behind some of the stories in the headlines. And from the sickness of flu to sunshine now, although even that sunshine might not be great, because the sun occasionally has storms of its own, geomagnetic storms. And when they happen, the sun shoots high energy particles out, and some of those can head towards the Earth. When those particles hit the planet, they can interact with the Earth's magnetic field and have all kinds of effects. If it's mild, it can create things like the Northern Lights, but strong ones can disrupt electricity grids, satellites, and even cause blackouts, but they are very hard to predict. Stephanie Yardley from University College London works on these phenomena and is looking into how to pinpoint them, which might make it a little easier to get a little warning. So Stephanie, how do these events happen?
We have disruptions that occur both in space and in the Earth's atmosphere. So a couple of the main things that we're concerned about is firstly crewed spaceflight. So there's a huge radiation risk associated with these events. And so this is important for astronauts, for example, or also airlines with passengers and crew. But also they can damage our electronics, particularly our satellites as well. So this is why we want to be able to predict these events so that we can mitigate some of the risk associated with them.
And then can you tell us about the work you've done helping to pin them down?
Basically, for the first time, we've found the specific source regions of these energetic particles. And to do this, we've used a specific chemical fingerprint. And we've used multiple space-based observations. So we have a satellite that sits in space that is measuring the particles that hit it there. And then we have another satellite that's looking at the sun's upper atmosphere. And we've basically found the same fingerprint in both these observations. And so we've essentially traced these particles back to the source region on the sun. And we found that these particles are actually confined low down in the sun's atmosphere and are constrained by very strong magnetic fields.
And then how does knowing where they are in the sun give us any indication on how to predict them?
We already put out alerts. So we have space weather prediction centres in the US and the UK that put out alerts for these strong radiation storms. However, we often get false alerts and these events don't arrive at Earth, or they're just not effective at Earth. And so really we need to understand more about the properties of the source regions to be able to understand whether these are going to be effective. And so what we can actually do is look at a source region then on the sun and say, well, we think this is going to essentially produce one of these particle events, and this will give us more warning. So currently a lot of the prediction that we do is in progress. So when an event has already occurred and the particles are arriving, then we can say, okay, we can model this event, and this is what the fluxes arriving at Earth are going to look like, which obviously is a bit late in the day to do so. So by understanding these source regions, not only can we look out for these source regions that are going to produce these events, we can also improve some of the models that we use to model these events.
And then how big a threat is this actually? Because it still sounds quite abstract in some regards. So what could it actually do?
So these events are quite frequent. They occur, there's about 100 events that occur every solar cycle. Now the solar cycle happens or is on the order of 11 years. So we get 100 events every 11 years. Not all events cause us issues here at Earth, and actually it's some of the more extreme events. So maybe we get a couple every 11 years that might cause an upset in some sense, or would increase the radiation risk to airline passengers and crew. So maybe once a decade or so, you might expect to receive over your yearly dose of radiation. And then we get these more extreme, even more extreme events that occur every 100 years or every 150 years, which would be absolutely disastrous and we'd have to ground flights essentially.
And just to come to you, John, what are your thoughts on this kind of thing?
I was thinking while you were talking that if you really get to the point where you can predict these things reliably, and reliability, I guess, is the key here, you actually stand to make a lot of money, don't you? Because there are presumably people around, such as, I don't know, power companies and people who look after communication systems, who would actually pay you a bit of money if you could give them reliable forecasts.
Yeah, I completely agree. Maybe in the future then space weather consultancy would be a thing. And this is something that they're already interested in. So you have, say, the National Grid are already interested in these things. We have a lot of what we call end users that are interested in using these forecasts. And even the airlines have started to be more interested in this. And the government have actually recently put £20 million into funding a huge project, which is how I'm employed. And this is what I work on now. So yeah, we're really interested in this. And hopefully over the next couple of years, we will be able to see some results.
And presumably, if we ever get to fly again, we should check in with you before we go to check if the sun is behaving on that day.
Yeah, this is the problem. The sun doesn't necessarily behave, and it doesn't behave how we expect it to behave. These events can be quite random. This just obviously adds to the problem of these events, but it's certainly something that we need to be considering, particularly for obviously crewed space flights, so astronauts going to Mars, but also for passengers and crew on airlines. And it's something that we don't think enough about.
Bahiji, when we were talking about Perseverance, you were quite excited about space in that regard. How do you feel about these kind of things?
So many years ago, I was a postdoc at UCL and I started a social enterprise called STEAMED Collective, where the aim was to engage the public with STEM research through street art. And I had the amazing chance to meet somebody called Steve Fossey, who's at UCL. And at the time, there was a beginning of him discovering a supernova. I think it's SN 2014J. And we worked together to collaborate. And that's when I learned about supernovas. And when we went to the observatory in Mill Hill and we got to look at the sun, which it blew my mind. You can tell I'm so excited. So I find it very interesting. We curated a street art mural in Brockley, part of Brockley Street Art Festival. It's still there. And one of the things in our discussion, we were talking about sometimes the separation between sort of what's going on in space out there versus how it relates to us on Earth. And so that's when I learned about the supernovas emitting different elements, and also even just how the sun engages with the supernova, and how the elements, one of the main elements that supernova released was iron, and that's why we have iron in our blood. We wanted to say supernova in our blood, but that didn't go down well. So we had to write supernova in our hearts. So this is just really fascinating. And I would love to know more about the connection between the space weather and Earth weather. And is it specific? Because you would assume it would affect the whole planet in one go. Is that the case? Or does it just affect different areas of the planet that are more susceptible to different things?
Yeah, so it's really interesting what you've just said, particularly the project I like to also engage in. We do like some space art, so I like to engage in those kind of projects, and they're really interesting and fascinating. And it ties in very nicely what you said about the supernova. So what we actually used is this chemical fingerprint. So we were looking at the ratio of silicon to sulfur, and this is how we located the particles. So similar to you talking about the iron in the supernova. This is another problem with these events. They don't affect the Earth as a whole necessarily. You might have locations where you see stronger effects. So you might see stronger effects in the UK or at the poles or in America. And so a lot of effort goes into modelling these particles and how they interact with the Earth's atmosphere, and also the eruptions as well, how they interact and what damage they cause. So it's really tricky. It's a really tricky problem with many avenues that you have to look at. So you don't have to just think about the sun, you have to think about the propagation through space, and then you have to think about Earth. And then you get these really interesting studies where actually, so for example, one of our particular events, they registered these particles at Mars, like with the Curiosity rover. So you can get these particles, energetic particles, and these eruptions making it all the way through the solar system.
In fact, we see aurorae, don't we, at Saturn and Jupiter. So that's a great indication of the influence of the sun stretches, as you say, right across the solar system.
Exactly, and some of their aurora is even more complicated than it is on Earth, because you've got all the different moons that are involved, and they're even more energetic as well, because the magnetic fields are stronger. So that's a whole different avenue that a lot of scientists work on as well, modelling the aurora on Jupiter and Saturn.
Stephanie Yardley, thank you very much. And we must leave it there. Thank you very much for listening, and thanks to our guests, Chris Smith, Matt Bothwell, Elizabeth White, Derek Smith, Stephanie Yardley, and to my special guests, John Zarnecki and Bahija Raimi Abraham. Next time, we are travelling back in time and unravelling how modern science is helping scientists solve the mysteries of ancient Egypt. The Naked Scientists comes to you from the Institute of Continuing Education at the University of Cambridge and is sponsored by Rolls-Royce. Thank you so much for listening, and until next time, goodbye.